All right, students, good evening and welcome to one more session of your World of Chemistry, your Vani ma'am. Right, so basically yesterday I've asked you what is the percentage of grade 10, 11th, 12th as well as NEET and JEE aspirants. So I have got in the community tab maximum more than 60% students are from NEET aspirants. So no problem students, all are my students only, but I thought I'll be doing the organic series, that is your NEET ABHYAS series. So in this series I've started with the organic, and remember I'm not going to pick up the questions and something. I'm going to give you the tricks which will be useful for your examination. So very nice tricks will be there, series 1, series 2, like that it goes on till your exam, but not so frequently, but I'll be posting it with beautiful content. Right, remember students, whenever we post a video, it is not like there are 70,000 students and only few students are watching. Please try to share. The students who are watching, try to share so that others also get benefited with us. Correct students? So we are working hard for you all, whether it is World of Chemistry or whether it is an academy, whatever it is, you're all our students, correct, right? So we try to put in 100% for you all to get that perfect information, and we all wish you should come up in flying colors. So let me start with this series. Let me explain. Here in this video, I have included general organic chemistry, topic number 1. Second would be a surprise which is there and very important thing for your NEET examination. That is something related to your organic name reactions. So please watch the video till the end. Don't just scroll it, because it takes hours and hours for us to make. Basically we think, okay, if I do like this, will the student be affected? If I do like that, will the student be gained, or if the student gets some sort of help from that, right? So let us start off with the first topic, that is your general organic chemistry. The questions which I have picked up, I'll be telling the trick what to remember, and the question also will be given here. Let's start. So please watch it till the end students. Okay, right. So here in this is a general organic chemistry. In this, the question is something like this: overall stability of free radicals. So here they have given an order. In the exam, they may give you a question. They may give you these questions, maximum of this, and ask you to arrange in the order. The first important thing you need to remember is the one which has maximum resonating structure, that is more stable. That is a common concept, correct? Yes. So among all these, there are 3 benzene rings. So phenyl rings are the 3 are there. So resonating structures are more in this. Next comes benzyl, allyl. The least is vinyl. So whenever you're checking free radical stability, first important thing, remember more number of resonating structures, more would be the stability structures. So here 3 are there, so more resonance, so more would be the stability. This is more stable. Okay, further, ma'am, what should I do further? Remember, always remember, stability depends of free radical. What if something has to be most stable, what are the factors? When something has to be, or something is least stable or less stable, least stable, what is this? So this is least stable, this is most stable. So what factors should be there? Remember, for something to be more stable or most stable, important thing is it should have the S character, whatever you should just it should have less S character. Remember, suppose means it is less character is less, means it is away from the nucleus. Suppose if it is least stable, what should you remember? It should have more S character. That means it is very, very close to the nucleus, and it's the nuclear force of attraction Z effective is more in that, right? And if it is less in S character, that means what has happened? The dragging capacity is less. It's nothing but lower electron affinity of which one? Of half filled orbitals. Suppose if I take least stable, here the electron affinity will be higher electron affinity, that I have to remember. Means these are the factors which decide the stability. Suppose if I take the most stable thing, because of these factors, these 2 important things, as I said, less S character and means it is away from the nucleus, and lower electron affinity means it's away from the nucleus. That's why such compounds are considered as highly stable compounds. Done. Such compounds are considered as least stable compounds. Done. So that is the reason triphenylamine or triphenyl methyl free radical has more resonating structures. One reason it's stable. This doesn't have compared to that. That's why it is less stable. This is fine, students. This is how you need to remember. So this is a series. This is the topic or the concept of the free radical. Now let us come and see the next concept. Very important concept in your general organic chemistry. Let us see the next question. Here basically this question is about the carbocation which they ask you. So here, as I said, the reaction intermediates compulsory trends are asked. You need to remember how to solve. What do we see in the free radical? We said more number of resonating structures, less of the S character, they are more stable. Let us come to this. Here you have a series of carbocations, tertiary, secondary, primary, methyl. Now among all these, here we said tertiary is more stable. What is the reason? Basically, if I have to talk about this reason, basically methyl or ethyl, whatever alkyl groups are there, no, when they are linked with this positively charged, methyl and ethyl, what is the concept? They are electron releasing groups, correct? No, right? So let us write that. What is the reason here? Why this is stable? Basically, more number of methyl groups. So either if you have methyl or ethyl, what do? Just now we said they are linked to this positive charge. They start donating electrons. So these are what? Electron donating groups. Okay, ma'am, what happens if they are electron donating group? What they'll do is, whichever carbocation it is linked with, it will increase this stability. Stability of this carbonyl. What happens? By increasing the stability, already this is deficient. By sending the electrons towards it, the the intensity of the positive charge decreases, isn't it? So electron donating groups, what do? They reduce the intensity of positive charge. Intensity of positive charge. The carbocation, whatever positive charge is there, that reduces intensity. Automatically, it becomes more and more stable. That means in the exam paper, if you see more number of electron donating groups, that is more and more stable. Suppose if they are electron withdrawing groups. So what happens? Electron withdrawing groups are what? Electron withdrawing groups basically are the nitro group. The electron withdrawing groups are nothing but the carbonyl group. Suppose if these groups are present in this particular structures, what happens? Automatically the stability decreases. So electron releasing groups are there, means stability increases in this case. Electron withdrawing groups are there, means stability decreases in this case. Isn't it interesting, easy? Okay, now let us see one more question. So I am just moving my book above. Now check. Next question. Order of stability of carbocation. Here that is alkyl, means aliphatic I have taken here. Now aromatic I am taking. Now again you see, what do you see? Whenever you see more number of benzene rings, that means first concept is carbocation is stabilized by resonance, as we did in free radical. So the concept which I'll remember is carbocation is stabilized by resonance. Okay, it is stabilized by resonance. Perfect. After this, after knowing this concept, next let me check which has more number of resonating structures. This has 3 benzene rings, more number. 2 benzene rings, compared to that less. Only 1 benzene ring, less. That means whichever has more number of resonating structures, it is more stable. So that is the reason the order of that particular thing is given in this direction. So what will we write? Same thing again. More number of resonating structures, more number of resonating structures, more is the stability. Okay, more is the stability. This is perfect. Now let me combine both the aliphatic and aromatic carbocation stability, and let us write one concept that is nothing but overall stability of carbocation. Let us check that, because you need to know both, isn't it? So overall stability together, let us write one order. Remember, so what did I say? More number of resonating structures, more stability. So among aliphatic, aromatic, if I combine together, so PH3, 3 phenyl rings, carbocation, this is more stable compared to PH2 plus, because one phenyl ring is reduced, one hydrogen increases. Next, CH2 So here 2 hydrogens, 1 phenyl ring, that's why it is less. Here 3, that's why it is more stable. Here only 1, less stable. Further, if I come to aliphatic, CH2 double bond CH2 CH2 plus. Further, if I come, because the tri or trialkyl will be there, this keeps donating the electrons, means compared to this is less stable. Compared to this is further. Here you can show resonance, that's why I took this. Further, here resonating structures, further I am reducing the alkyl group, further I am reducing the alkyl group, and coming to your ethyl. Further, final, the least stable is methyl, because there is no neither resonance in this case, there is no pi bond, if I have to tell you, right? That's why methyl carbocation is the least stable, triphenyl carbocation is the most stable. Perfect, students. So this is your carbocation stability, remember. Now let us see one more. Here if I have to see, now next question, what did I take? Let me see whether the book is under the frame of the camera. Yeah. So the next question is stability of carbanion. Carbanion, from where I have derived it from? Alkyne, alkene and alkane. So basically here you need to remember, here ma'am, okay, hydrocarbons are there. I can decide based on their hybridization. Here in this case, S character is 50%, P is 50%. Here it is 3366. In this case 2575. Now what should you remember? Always remember the correct trick or the reason is, what should you remember based on hybridization? Greater the S character. Greater the S character. Yes, yes students, greater the S character, you are able to understand, because S I took, closer it is to the nucleus. It is to the nucleus. That means Z effective is very, very strong in this. Closer to the nucleus. Perfect. If it is closer to the nucleus, what will happen to this one? Lower energy. Lower energy. Now check. Here S character is 50%. Correct. So here this is more stable because it is very tightly packed. I can't pull it outside, I can't break it, I can't divide, means I require low, this one. So here it is the lower energy mixed together and bonded together. So whichever has more S character, that is considered to be more stable. So please write, whenever you have your hybridization, you can take it in that way and decide. Resonance also will decide, hybridization also will decide about its stability. Right, let us come and see the next topic. Right students, now let us see the next question, that is order of stability of alkyl carbanion. So here remember, free radical we have seen, carbocation we have seen. Now let us see the carbanion. So carbanions are nothing but negatively charged species, isn't it? Carbanion. Right. So here they have given an order. Methyl carbanion is more stable than this one, or primary carbanion is more stable than the secondary ethyl. Then tertiary, this is your tertiary carbocation, carbanion, where you have 3 alkyl groups. Now how did they predict this? How should you remember? Remember, in this first case, when it is your methyl, what is happening? Compare, if I check first and second. So here in the first case, in methyl carbanion, what happened? There is only one, there are 3 hydrogens, correct? There are 3 hydrogens. When I take here in tertiary, there are, okay, this is 3 hydrogens, this is 3 alkyl group. Okay, so whenever alkyl groups are there, what is the first thing you should remember? Alkyl groups are, or more alkyl groups are there, or whether it is methyl, more alkyl group, what will be happen? More electron donating nature. Electron donating nature. If it is more electron donating nature, what can I say? It shows plus I effect. Correct? No? Plus I effect. Now here, when I see this, lot of plus I effect is there because this also donates, this also donates, this also donates. Because of this, what happens? This electron reducing nature, it will intensify this negative charge. Whatever is there, the negative charge is intensified, means it increases so much that it destabilizes the carbanion. So what should you remember here? When there are 3 alkyl groups, more alkyl groups, more plus I effect. More plus I effect means more negative charge, more negative charge intensifies on which one? On this carbon. The cloud, the electron density becomes more, intensifies on carbanion. Carbanion. Because of this, what happens? Because of this, it destabilizes the thing. That's why tertiary is unstable. It's not stable compared to primary. Now when I take primary carbanion, there are only 3 hydrogens. Are you finding any inductive effect here? No, there are no alkyl groups. That's why there is not much appreciable inductive effect. That's why it is most stable. So no inductive effect. That's why it is most stable. Perfect, isn't it? Right. So we have seen for free radical stability, we have seen for carbocation, we have seen for carbanion, correct? Now let us see the overall stability. Okay. So here when you take the overall stability of your carbanion, remember overall stability is triphenyl methyl greater than benzyl, greater than allyl, greater than primary, greater than secondary, greater than tertiary. This is fine, students. Okay. Now let us turn and do the next thing, carbenes. Okay. Now next reaction intermediate, carbenes. So here in carbenes, what is the order? They have given this order. Okay. Methyl. Tertiary is given, secondary is given, primary is given, okay, ethyl is given, methyl is given. Carbenes, when I check these carbenes, so basically triplet, we call it as triplet carbene, doublet carbene in this way. So what should you remember in carbenes? Basically, if I have to check, triplet carbenes are relatively more stable. Triplet carbenes are more stable than singlet. What is the reason? Because what happens is when I have this triplet, energy, is required to place 2 electrons in the same orbital. Correct? No? Right? So why? Because when I have to place that, I have to place 2 electrons, triplet. No, 2 electrons in the same orbital I need to fit, and because I have to fit it and then overcome the interelectronic repulsions. That is why always remember triplet carbenes. So basically what are carbenes, students? So normally we have studied in the general organic chemistry different types of reaction intermediates. So carbene is a molecule containing a neutral atom, correct? No, with a valence of 2 or shade, like basically 2 or unshaded valence electron pairs, correct? No. So here when I take carbene, here in this case I said I'm talking about triplet. Correct? Now here this minus, if I have to just not consider, because carbene means you should have pair of electrons, which I said, isn't it? So carbenes, just check, don't like just simple, keep this aside. Now as of now, I'm just taking this out, and you take triplet carbenes are more stable than your singlet carbenes. Triplet carbenes are more stable than singlet carbene. So basically when I take triplet carbene, how does it look? So triplet carbene means, as a name suggests, it has triplet and singlet means, as a name suggests, they are, just check this triplet carbene, it looks like, see, there is 1 pair of electron. Please don't take this, don't get confused, I'm showing it here. There is a pair of electron, 1 here. Okay, I need to take this because I have to fit both the electrons in this. 1 more, and hydrogen, and this is hydrogen. This is your triplet carbene. If I have to take the singlet carbene, you have the orbitals in this. So I have to place both the electrons in the same, isn't it? That's what I said. I need to place 2 electrons in the same orbit. Correct? So because of this, there will be, what will be there? There will be inter-electronic repulsions. Electron repulsion will be there. Because of this inter-electronic repulsion, what happens? It is going to just have or less stable compared to triplet. So always remember, triplet carbene is more stable than singlet carbene. This is fine, students? Okay, sorry for this inconvenience. Now next comes your nucleophiles. What are nucleophiles? Basically, nucleophiles are electron-rich species, correct? No, so I can call them as Lewis bases also, correct? Electrophiles are Lewis acids, nucleophiles are Lewis bases, which donates electrons. So what are the common nucleophiles we normally see? Neutral. They are neutral nucleophiles, correct? They are pi bonded nucleophiles. They are negative nucleophiles. So ammonia are NH2, right? Next R2NH, done. R3N, done. These are all electrons, no? Right. Water, right. The next comes alcohol. These are all list of nucleophiles which you will be using regular basis. Right. Next comes cyano, very strong. OH minus. These are all negative nucleophiles. Correct, no? X minus, OR minus, SH minus. Right. This is RCOO minus. And then alkyne minus. These are all nucleophiles which are which act as Lewis bases. Remember that. So they are electron rich species. They attack the sites where there is electron deficiency. Now electrophiles. So electrophiles are what? These are electron deficient. These are basically Lewis acids. They accept electrons always. Correct. What are the different electrophiles which we have studied? We have studied boron trifluoride, aluminium chloride. In Friedel-Crafts reaction we have studied, isn't it? In the presence of a Lewis acid we said. Next comes FeCl3, perfect. Then SiCl4, done. Then comes your SO3, done. Then CH2, yes, it can be a neutral molecule also. It can be H plus, it can be Cl plus, it can be Br plus, it can be NO plus, it can be NO2 plus, and it can be Rc plus double bond O. So many electrophiles are there in our this one which you will be using, which are electron deficient, and I call them as Lewis acids because they keep accepting electrons because they have, or if I have to take like particular thing, they are electron deficient and they require electrons. Correct. Now let us see some more important points to remember in general organic chemistry after the reaction intermediates which are frequently asked. So after the reaction intermediates, the next thing which you have to remember, the important points of the exceptions which they keep asking. Okay, so let us discuss. So here always remember, they'll be asking questions about sulphur trioxide. So what is the structure of sulphur trioxide? Basically sulphur is in the center, 2 oxygens above, 2 more oxygen, 1 more oxygen here, 1 more oxygen here. So 1, 2, 3, 4, 5, 6, 7, 8. Here in this case, if I have to take the same thing, 1, 2, 3, 4, 5, 6, 7, 8. Here also the same thing in this case. Okay. Now here what happened? There are how many lone pairs? 1, 2, 3, 4, 5, 6. 6. If I have to just check the lone pairs and bond pairs. So basically 1, 2, 3, 4, 5, 6 lone pairs, and there are 6 bond pairs. 1, 2, 3, 4, 5, 6. Correct? Right? So they are located in such a way that the geometry is trigonal planar. Trigonal planar. This is a Lewis structure. So trigonal planar geometry is there for SO3. I don't know, maximum they ask the structure students depict it wrong. So that's the reason. Remember, it has 6 lone pairs and it has 6 bond pairs also. Right. Now next structure which is very important is IF7. So IF7, as we know, it is your pentagonal, correct? No, pentagonal bipyramidal geometry it has. So let me write that. It has pentagonal bipyramidal geometry. Okay, these are all exceptions basically. That's why they keep asking you these only. You need to remember. So how does it look? 7, no? I is in the center, right? 7 are there. So 1. So if I have to draw 2, I'm joining. Next 3, done. Then I'm joining 4, done. Then I'm joining the 5th one, done. So let me join all these 1, 2, 3, 4, 5. Right, till 2 more are there. This is at the back of the pair ring. So this is your F, and 1 more, 1 at the front, 1 at the back, 1 at the back. Done. So this is your IF7 structure, which is pentagonal bipyramidal geometry. Remember? Okay. One more question which they ask: what is the molecule or the ion which is an isoelectronic with CO3 minus? So normally they ask this question, quite common, which I have checked. So remember, NO3 minus is in or is isoelectronic, same number of electrons, isoelectronic with which one? With carbonate ion. So both are isoelectronic, they have equal number of electrons, and what is the geometry? They have trigonal planar geometry. They have trigonal planar geometry. These are all exceptions. So you should remember, that's why I picked up. Next, they'll ask you one more question. What is the species which is an isoelectronic with I3 minus? So that's nothing but interhalogen compound ICl2 minus. So this and this are isoelectronic in nature. So you can have it as a question. So remember that. Next, one more is the species which is in isoelectronic with XCF2. So XCF2, the species is ICl2 minus. So this is one more also, I, small I. Done. This is one more. So these are all very important questions asked. And what do they have? They have a geometry of trigonal bipyramidal. Trigonal bipyramidal geometry both have, and the geometry and the thing which they ask. And next, except if I take this thing I'm talking about, if I take XCF2, it is linear in structure. No, XCF2 is linear, it is straight, X in the center, fluorine on this side, one fluorine. So this is your linear structure. So what am I trying to tell you? These are all important exceptions which they ask you. This is one exception, that is one more exception. Now let us see the important part of your organic chemistry, that is nothing but a beautiful way of learning the name reactions. Let's see that. Right, students. So as I said, name reactions, how to study. Normally name reactions, ma'am, very difficult. So what did I do? I have divided all the name reactions, almost 100 plus name reactions, into 4 different tables. What is that? This is your name reaction, name of it, reactant, reagent, product. What is the advantage of this? This advantage is whenever you are learning the name reaction, either if they ask you all the 4, so if they ask you what is the type of the reaction form when aldol is a product, so aldol condensation, the reactant is aldehyde, and the reagent in the presence of a base only, it's going to happen, dilute base, like that. So I have listed out almost 100 plus reactions according to the alphabetical order. So here I have taken as acyclone condensation, reactant is this, reagent is this, product. Then aldol is taken here. In the next page, cross aldol. So basically cross aldol you will be studying, no? Cross aldol you will be doing? You will be doing the cross between benzaldehyde, acetaldehyde, ketone also, formaldehyde also. So I have taken all the options. I have written what is a reagent required and what is a product. Perfect. Now next, let us see some more. Here this is one more name reaction with A. I have taken that. This is Beckmann reagent reaction. Name of the reaction, the reactant, these are the catalysts or the reagents which I take. In all the cases, some are catalysts are there, some are reagents are there, and this is the product. And next comes bridge reduction. Now this is one more, bridge reduction Cannizzaro. So this is the name of the reaction. These are the reactants, these are the reagents or catalysts or solvents, and this is the product. Perfect, isn't it? Yes, you can take the screenshot also and use it. Further, I have divided some more name reactions starting with C. What are they? I have taken with Claisen condensation and Claisen-Schmidt reaction. Name of the reaction, reactant, name of the solvent or the catalyst or reagent, and the product formed. Perfect. Yes. Next, student. Next, further I have taken it took a lot of time for me, students, doing this. So Clemenson, Curtius, Friedel-Crafts. So these are the reactants, these are the reagents, these are the products. So quickly you can note it and put it and stick it to your near the study table and study it off. Like that I have done for Friedel-Crafts acylation reactions. See here, Friedel-Crafts acylation I did. What is the reactant, what is a reagent, what is a product. Further, I also did Finkelstein reaction, Woods reaction, Fittig reaction. All the 4, if you see this, all the 4 are there. They may ask you, they may give you this, you need to write this. They may give you this, you need to write the solvent or reagent. That's why it is very, very important thing for you all. Right, students? So, this is from your Vani ma'am. As I said, this is your NEET series which I have started. Thank you so much. Remember, students, I have taken almost a lot of time to do this. This is your organic series 1. So this is your NEET ABHYAS organic series 1. So here basically, don't worry grade 11 students, I'm there with you all. I'll be doing, let your seniors finish off your NEET exam, then I'll come back to you. So organic series 1, in the next thing I'll be meeting again with next series. So next series coming up very soon. next series within a week time. Next series 2 will come up very soon. Thank you so much for watching. This is your Vani ma'am signing off. Always remember, keep smiling. I'll meet you again in the next series. Thank you so much. God bless you all. Stay happy. Please watch, share, subscribe, and remember to share, because world of chemistry is something which without you all it is not there. I keep always saying, world of chemistry is only because of you all. So if you all share, only I can upload. If you are not showing interest, I will also lose interest, isn't it? Thank you so much, students. Bye bye. Thank you, and meet you next week. Thank you.